Good evening, everyone. This is Vincent, and welcome to this coffee break number 11. Today, we are here to talk about Substance 3D Designer and especially about the pixel processor node. So, the pixel processor node is one of the most powerful nodes in Substance 3D Designer, and we are going to see today how to start with it. So, I'm not going to build complex things, but we are going to see how it works, the logic behind it, etc. Before to start, as always, I have the chat in front of me, just here. So if you have any question, if you want to chat, about Substance 3D Designer, about what I'm presenting, or Substance 3D in general, don't hesitate. I'm here to answer. Also, tell me if the music I choose something, if the music is too violent for the stream, if it distracts you, just tell me as well. So I'm going to share my screen, and before to delve into Substance 3D Designer, I'm going to show you a bit of Substance 3D Painter because we had an update 2 days ago. So just it was the 9.1.0, and we did some cool stuff. One of them being now we support SVG file support, which means that if you work in Illustrator, for example, you can export as SVG, which is a vector file, and you can import it into Painter, and this way you don't lose any quality regardless of the scale for your image. So this is great. We made this with designers in mind, but I'm pretty convinced that it could help any industry. If you work with logos, any graphic stuff that you have to apply on a 3D mesh, well, this is for you. This one is maybe, it's a quality of life, but if you are a long-term Painter user, you will love it because now you can just drag and drop any resources anywhere. Before, if you remember, you had to first import into the shelf, then define what kind of resource it is, and then you are able to drag and drop it within the UI, whether the properties or the mesh itself. Now you can directly drag and drop on the properties, on the mesh itself, on the layer, whatever, it will work, and that's great. I think it will save a lot of click. This one is related to Adobe standard material. Now we have been making sure to support transparency within it, and for this my colleague Lena built a great French restaurant table scene, default scene, just to showcase the UV tiles, and the scene is great. So if you want to open it, to play with it, that's a good playground. And finally, you know that the previous major version, I think, we introduced the 3D path, which allows you to do lots of things. And now we just have added some Bezier curve handler to have even more control. So that's it for the small parenthesis about Painter. And now let's talk about the pixel processor. So this is arguably one of the most powerful nodes of Substance 3D Designer with the FX map. And 2 weeks ago, I think, we have been making an introduction for the FX map. And this is a bit the same philosophy, in a way that for the FX map, what we do is we build pattern and we define a logic, which is for each pattern, do this. Well, the pixel processor is the same, but for pixel, which means we are going to build logic for each pixel. So if we look at the node itself and the properties, you see that by default there is not a lot. You have first the color mode, you can go color or grayscale, and then you can edit it. So get into it. So I can click here or do Ctrl E, and it will do the same. And when you enter, you just have this float 4 node. I am in color, but even if I am in grayscale, this is the same which is appearing. As you see, it's yellow, so it means that it's set as output. So this result is outputted. As you may know, in Substance 3D Designers, values or colors are a bit mixing, meaning like here, this float 4 will represent a color. So this is a number between 0 and 1, a number between 0 and 1. But also this control a color, meaning that the first is red, green, blue, and this is the alpha, meaning the transparency. So if I do this in the parameters, just doing this, you see that I can change the red, the green, the blue, etc. So this is great, but you may say, okay, that's a bit useless because we have the uniform color node which does exactly the same, and furthermore it may cost less, and you're right. But the thing here is that right now I'm applying this to the full pixel, all the pixel of the image, but you can also create some rules to control, to make some specific recipe for each pixel. So, and that's how it works. So the rule for a pixel processor is this one. I'm going to write it as a comment, like this. Once again, don't forget that I have the comment close to me, so if you have any question at any point, just ping me and I'll try to answer as soon as possible. So in the comment, I will say, so as a reminder, for each pixel, do this. So I'm just going to remove this, like that. So for each pixel, do this, and everything that we are going to create here will be applied to each pixel one at a time, which means that it will take one pixel, do the processing, then goes to another one, do the processing. And this is very important to understand that this process is done individually. For example, you cannot say for each pixel, look at all the other ones and make something. No, it will just look at this one. What you could say, for example, is for each pixel, look at the one around and do something, but you cannot, this is very individual. Also, when you are on one pixel, you cannot say, while you are making the process on this one, draw something on another pixel. No, this is not possible. You are just affecting the current pixel. So this is really, this is controlled by GPU as well, so it's made in parallel. So that's some notions you have to understand to know what's feasible and what's not feasible. So here, what happens is we say for each pixel, apply this color. And as I say, do for one, then the other, then the other. But here, the order is the same. It just applies this color, so there is no change. So we have, the first thing we have to think about when we work is to find a way to isolate each pixel, to make them unique. So we have to think of a pixel and what we could say. What could we say? What is unique for each pixel? In that case, I'm going to go and put myself in grayscale mode. It will be easier. I will have less. And by the way, just to show you something, you see that even if I am in a grayscale mode, this is working. Generally, when you have a parameter with the function graph, you can just output the same type as the parameters. For the pixel processor, you can either output float 4 or just float. Or like that. It's just for the sake of simplicity. This way, even if I am in grayscale, I can change the color, it will work. I cannot, float 2 wouldn't work because it cannot be a float 2 because it's either color or grayscale. So in my case, we are going to stay here in set as output node. This way I control with one node. Okay, so we have to find a way to differentiate each pixel. So an easy one is to say I can use a random. For example, if I use a random node, for each pixel it will choose a different random node. And for example, here I can say we have a random here. So as a reminder, the random node works this way. It will choose a random between 0 and the value that you are going to put as input. So here, for example, I'm going to put this as output. So for each pixel, pick a number between 0 and this and display it here because it's the output. So if I increase that, you will see that it will create, I will put between 0 and white, which corresponds to black and white. You see that each pixel, oops, sorry, like that. You see that I have different values. I have 256 shade of gray, better than the book. So this is a way, but that works, of course, but you don't have a lot of control, obviously, because it's random. So if you want to create a random noise, you can use this one, of course. Now, this is not a value which is unique to each pixel. This is a random value, so it works, but is there a way to find something that would be unique for each pixel? And actually there is one, which is the position. Each pixel has a unique position which is not the same than all the other ones. So we have to find a way, relying on the position to create some effects, filters, etc. could be a good solution. And that's what we're going to do. So I'm going to leave this for now, and we're going to delete it later. So how to get the position of each pixel? Well, I just said half of the solution. We have to use a get node. So if I do spacebar get, you see that I have different ones, like this one. And we are looking for a position. A position is a float 2, because you have x and y, and it's between 0 and 1. Get float 2. Just so you know, in Designer, the 0 is at the top left, then 1 on x and 1 on y. Why is it's like that? It's because, well, this is the theoretical good way, because an image is drawn from top left to bottom right. So we decided to put the 0 here. So with this node, you see that now I have a gate float 2, and I have this warning because I have to say, okay, what you have this node, but which variable do you want to get? And luckily, Designer is generating, always generates a built-in variable, which means that you don't have to create them, they are created by Designer. And one of them in that situation is the $pose. So the $pose is getting the position of each pixel, of the current pixel. So now we have, like, for each pixel, do this and do grab the position of this pixel. So what can we do with that? We can do many things, of course, but one of them is, for example, we can use another interesting node, which is the sample gray or color node. In my case, it will be gray. This node will take as input a position. Perfect, we do have one, and it will return the value which is present at this position on the input 0. Well, let's go back at the main graph level. So far we don't have anything. So what we're going to do first is to grab an image. Let me check here in the library, texture generator. I can take something like that, for example. So let's say I want this. This will be my first input, and look, when I'm plugging this, you see that I have a new one, a new input which is created. So the first one is input image 0, this one is input image 1, and if I put another one, it will create, etc. So this way you can use as many input as you need. In my case, at the moment, I will take one, but later on we are going to add a second one. So now if I go back here, if I say for each pixel, do grab the position and display, draw the value which is present at this position on input 0. You see that here when I select, I can select different inputs. Right now I just have one, so but this list is dynamic. Doing this, I set as output node. Sorry, I'm going to do it after. Let me take another one. Set as output just temporarily, because first I'm going to double click here to see that it's black. And know what it will do. Well, it will draw what's in the input. So useless for now, but at least you get the logic behind this. So for each pixel, grab the position and draw the value which is an input 0 at this current location. Now, okay, that's interesting, but let's do something a bit even more interesting. The good thing right now is we can do something per pixel, which is great. So let's imagine right now I want to create a warp, like a horizontal warp, which means that to move the values. First of all, the first step would be to just move everything at the same speed. To do this, well, if I want to move horizontally, it means that I want to work on X. So I have to find a way to isolate the x-axis. And for this, once again, there is a family of nodes which are called the swizzle, and which allows you to do exactly that. What it does is you can create a float 1, float 2, float 3, or float 4, and by just using values from another node. So let's see that. In my case, I want to isolate just x, so I need just a float 1. So when I do this, I can put this inside. I can put a float 2, a float 3, a float 4, it will work. And when I'm here, I can say, okay, this new float 1, which value do you want to use? I want to use x in my case, but sometimes it could be y. If you have a float 4, you can choose whatever value which is present here. And please note that, for example, if I do, for example, swizzle float 3, like that, here I can say, okay, this is a float 2, so I can say, you know what, I want x, x, and y, for example. Or x, y, y, x, y. You do whatever you want. The swizzle just allows you to play with these values that you are going to plug and create a new float or float type. It can be float, integer as well, etc. You get the idea. So this will create just by plugging one node, and there is another type which we are going to see after, which are the vectors. So the vectors, they are going to merge multiple values. For example, I can say vector float 3, so it will create a float 3 just by using, for example, this and that. So here it doesn't work because I'm trying to plug a float 3 into a float 3, so it will say, okay, there is a problem because you cannot do anything. But I can take this and once again, for example, do a swizzle if I would need float 2 and just take x and y and putting this. So here I have 3 values and I would create this. So swizzle and vector. Swizzle to create a new float type based on one node, and vector to merge values into another one. This is really handy to play with your different values. So let's continue. So I have my swizzle float now, and I say I want to make like a feeling of movement. So what I could do is to say, okay, I grab this pose, but for what I'm going to draw a vertex which is either there or there. So I can change the position where I'm going to pick the color. I won't be able to draw in another place, but I can pick the color in another place and apply it here. To do this, I'm just going to make a simple addition. Oops, sorry. Like that. I'm going to make some space like this. So addition is the x plus a float at the moment 0. And what do I do now? Okay, I have this. This is a float 1 and this is a float 2, so it's not compatible. If I do this, we have a problem. By the way, if you look at the color, you will see that the float are coded from this green to blue for float 4. This one, you see it's a bit bluer and it goes more blue up to float 4. So just to help you visualize, these are the float. For the integer, it's from yellow to orange, and there is like orange red. There is some variation between both. That's just visual helper. But once again, if you have some red red links, it means that there is a compatibility issue. So that would be a trick. So here definitely I cannot put a float 1 between a float 2, and this one anyway is waiting for a position, so x and y. So here I want to modify x, but I don't want to modify y. So what I will do, I'm going to select this swizzle float, Ctrl D to duplicate, but this time I will say grab the y value here. And as I said just before, we can create a vector to create a new float 2 that will work. So I will get my new x and my existing y and plug that here. So at the moment it didn't change anything because I added 0, so it doesn't change. But if I select this, now you see that it changed on both sides. So this is cool. This is something that you can do with a transform, but once again, you start getting the idea of what's going on. And if I want to be funky, I can say, you know what, I would love to have this one affecting also Y, but in a different way. For example, I can say in Y, we are going to maybe make an addition as well, like that. But this time I'm going to multiply this by 2, so it will move twice as fast on Y than on X. I don't know why you would do this, but why not, no? We're here to learn. We can do everything we want. So here I would say multiply by 2. By the way, you may know that, I guess, if you drag and drop and release, it will show just the compatible node, which is great. So in my case, well, first I'm going to do this, so it will help. So this one, I know it will be a float, and I will do multiply by 2. And this I'm going to replace here. So now, if I move, you see that it moves faster in Y than in X. So that's, I don't know if it's useful, but I like it. Okay, really nice. But once again, right now, it's making the same translation for each pixel, which is great. It's already a good start. But what would be interesting is to say, okay, but what if I want a different strength for each pixel? How would I do that? Well, we can work by pixel. We have seen that. So one of the ways to do that is to say, well, we can use another image, maybe another noise map, and take the value of each, the grayscale value of each pixel, and use this as a multiplicator of the strengths we have here. So that's exactly what we are going to do. So first, going back here, and we are going to choose a noise. Let's choose an interesting noise. Let's go with this creased, which is like, well, noisy of course, but yeah, could be fine. Okay, disorder, let me check. We can play with that, warp intensity. Not that much, like that. Okay, so we have that, and I'm going to plug it here. As you see, a new one is created just in case. Going back within this, and now, as I called here the input 0 with the sample gray, before to make all this modification, I can call the input 1. So I'm going here, I do sample gray, like that. And here, now we get the value of each pixel. If I put this in output, for example, oops, I see, yes, okay. It's because here I didn't put the input image 0, I have to put 1 here. And now you see I have my second input. So just doing that, I can make sure that I have the good information. Let's put this back. By the way, this is a good way to check sometimes within your graph. If it's a float 1 or float 4, I can go here. Here it will put a pure white because it's like burnt. You have to remember that black is 0 and white is 1. Above 1, if you are in 8-bit or 16-bit mode, it will be burnt, which means that it will be pure white. If you are in 32 bits, I'm going to show later, you can get back to the value, but we are going to see that later on. So I'm going to put this here. And now I want to use this as a multiplicator, we say. So let's do that. I can go here, my value, my position a bit later on. And here let's do multiplication. Multiply, like that. And just a trick, if you hold shift, you can unplug everything and replug to another place. And now it starts to get interesting. So let's put this as 0. And you see that right now, just by moving this, I create this warp. So what is going on right now is, if we look, it will move faster in the light place on this, and slower when it's black, let's say. So each pixel value is influencing my result. And you give this. Hakuto, hi Hakuto, who say, I did not know there was this tool in Substance. Yeah, this is a tool, or more exactly, this is a node, which is the pixel processor. But this kind of function graph is present in all parameters. For example, I can go here, alveolus, and say tiling here, and intertext. I can enter into create a new, so it's cut by the screen, but it's written expose as new graph input, and below you have empty function. It's just here. I'm here on the right, you can see. And when you do empty function, you have this kind of graph. And so even in parameters, you can create this kind of logic. The advantage of the pixel processor is that you can create this kind of logic for each pixel. So meanwhile, when you are into a parameter, what you are going to control at the end is the result of the parameter. And talking about that, we have seen that we have, I showed that there is the get float to, the dollar position, which is accessible by the get float to node. And this one, as I say, it's the built-in variable. This means that it's generated automatically by Substance 3D Designer to help you. And depending on the concept text, you have different ones. So I'm going to show you most of them, not all of them, using this value processor. So as we say, the pixel processor will display pixels and can treat pixel one by one. A value processor works the same way, except that it will generate a value. So it can be a float 1, a float 2, an integer, a boolean, etc. You name it and you choose it. So why I chose this one right now? Because a value, this way I will be able to show you what hard-coded variable corresponds to. So let's go into it. So these are not all of them, because the one we are seeing right now are the ones which are compatible with the value processor, but there is most of them. So here you see that I put the get, different gets to get the values. And in the get float you have 3 which are useful. It's the get float 1, get float 2, get float 3, and integer 1 and 2. So let's look at this one first. So I'm going to put it as output node. So we see here, this is the dollar time. So you may or may not know this, but technically you can animate a substance material or substance filter or whatever. And to do this, well, you will use a dollar time, which means that it can influence the result depending on the spent time. And this is something that you can access in a pixel processor or a value processor, for example, to affect your results. You can say, for example, that the color is changing depending on the time. Well, if you want to do that, you will use this. If you want to watch an animation, you have to go in Substance Player. I really hope one day Substance 3D Designer will make it natively, but it's not yet the case, if I'm not wrong. So get floats, you have access to dollar time, and you see that all the hard-coded variables have the dollar sign. Now let's look at this one. Get float 2, there are different ones. There is first the dollar pose that we have seen. It's not present here because there is no pixel in a value processor, so you cannot really use it. It outputs a value. But there is the size here and the size log 2. So the size is kind of easy. It's the current parent size. The parent being the application that is running your Substance project. Here it's 2048. Well, if you look here, you see the current parent size in the graph. So if I change this, well, it changed the value. And the size log 2, this is why it's great to have the value processor, because for many people, they were seeing the size log 2 and weren't sure about what it was about. So this is this number, so 11, and it corresponds to the size. Once again, as you say, you know, in Substance 3D Designer, the size is always 2 power of something. So it's, for example, it's 2 power of 1, 2 power of 2, 2 power of 3, etc. So this is the power it corresponds to. So for example, 2048 is 2 power 11. If I go back here and I put 124 power 10. This could be useful in some cases, depending on what you want to build. If you need to access this level in this shape, it can be useful. It's easier to read. Sometimes it's easier to process. So that's a good way to work. Markel Carter, I hope they integrate Substance Player one day. I hope to. Honestly, that would simplify many things. So I think for this one, that's about it. Yes. So let's go to the physical, the float 3, sorry. So double click and right click to put that output. Physical size, this is something quite recent, I think 1 year or 2. This is something that you can define in Substance. When you are creating a material, you can now define a physical size for it. For example, if you are making a fabric and it's supposed to correspond 30 centimeters by 30 centimeters, you can go in your attributes here and set it here. So you can say, you see in centimeters, you can say 30 by 30 by maybe 0.1. So why is it useful? This is something we want people to do more and more. This is really important in my opinion, because it allows you, when you go to Painter, for example, or any application that supports physical size, to just drag and drop your material, set it up as physical size, and the tiling will be perfectly applied. This is extremely handy if you work in a game VFX, and it's almost mandatory if you work in a real product industry. When I say real product, which means that there is a final product in the real world, like fashion, automotive, RVs, etc. Why? Because this way you are sure that what you see virtually will correspond to what you will build. So it saves a lot of time. Once again, it requires consistency in the pipeline. It means that you have to define the size properly here, of course, but also making sure that your object is at the right scale, etc. That said, you have a way to access this value in a pixel processor and use it at your will, so it can be handy as well. Will have a question that is unrelated to designer. Okay, I'm letting you prepare your question, and if I can answer, I will. So let's continue here. So we have this one. I think there is just this one. Okay, so now let's go to get integer. This one. So I'm going to put it as output. So we have the normal format. If you work in video games or VFX, you may know that there is two main formats, which are OpenGL and DirectX. And these people weren't able to to agree on keeping just one. So the only difference between OpenGL and OpenGL DirectX is the green channel, which is inverted. So there is not good or bad, but sometimes if you're in Blender, it will be OpenGL. If you go to other application, especially Microsoft One, I think, because I think they created that, it's DirectX. So this way you can control and adapt. You can put even a switch and say if OpenGL put this one, etc. So that's a way to control this point. So the question of Will is, I've been trouble in Painter with importing any big amount of mats that I've bought into the shelf. How do you view a lot of smart material to choose when using Painter? I have 64 gig of one. I will donate. You don't have, you can't donate, but that's fine. Well, it really depends of the material, and the RAM is a thing. It depends also on the material. It should work at some point. Yeah, that's very tricky to answer here. I would invite you to go to our Discord. I think it's Discord, discord.cc/substance3d, if I'm not wrong. Let me check. I hope it's this one. I have to put www. Okay, this. Hope it works. Well, look at our Discord. That's easier to answer because it can be, it should work, but I cannot see the materials, etc. Make sure also that you import let's say, what you need. If you import everything, you're just going to overload your UI for nothing, I would say. So in theory, it should work, but it depends how the materials are done, etc., etc. Sorry for these parentheses. So normal format, and this one, tiling, I'm not sure of. I've been asking, I didn't have an answer right now. I tried to see if it corresponds to the shader tiling, but I'm not sure. So, but you can control it. I will have to look at the documentation. Then integer 2. So this one, UV tiles correspond to, well, if you know UDIMs, for example, UV tiles is the same. It's like different UV space in the, it's the UV space coordinate. So you have 1, 2, 3, 4. Well, you have 0, 0, 0, 1, 0, 2. If you have to make something specific regarding of the UV tile, you can do that. You can say if UV tiles equal the coordinates you need, do that. Okay, so I'm going to, this was an interesting parenthesis in my opinion, because you may need these values and sometimes you don't know what you have access to. So this way you can play with. Okay, so let's go back here and let's see. Now we have seen we can control lots of stuff. We have seen the dollar position, which may be the most important hard-coded variable, built-in variable that we do have. We have seen the swizzle, which are here. Once again, that's a way. Swizzle and vector are two ways to manipulate data. You have a lot of ways to make some math. If you look, so before you see first, you see the gets. You have all the gets to catch a value, and then you have you can even catch string somehow. Then if you go, you have like all the value that you can create from scratch, like integer, integer 2, float, etc., etc. And if you start the swizzle, the vectors, so it's well organized, honestly. And you can also have this kind of the 2 integer and 2 integer 2 to integer or 3, etc., and 2 float, etc. Why? Because as I explained before, values are specific, which means that you cannot multiply a float by an integer, for example. So imagine, for example, you want to get an integer. So let's say, for example, it does not make sense, but it's just for the example. So I'm going to take the get integer 2 here, and I'm going to grab the... Ah, no, interesting. I was looking at something I was expecting to be there. So I'm just creating an integer. Let's say that you grab it for somewhere else when you decided. Like that, and it's 3. And what you would like to do is to, let's say you have 3 images and you want to pick one randomly. So you would like to make a random between these 3 images. So we do have a random node, but as you can see, it's expecting a float. So this is where you are going to use the 2 float, which allows you to pass from one integer to a float. Like that. And now this one can be either, well, it will choose, in that case, if you want to choose a value between 0 and 3, what you will say is, let me check, you may add, because here it will make between 0.0 and 3.0, and sometimes it could be 1.5. So behind that you may add a floor, for example. A floor value, what it does is everything which is behind the decimal will be skipped. So if we would like to, like that, floor. So if you would like to be between 0 and 3, you may have to say, okay, I'm going to put 4 here. And this one, it will be, and this one, there is like a really small chance that there is 4. If you want to be precise, you can say, for example, random, and just make a subtraction of 0. 0.01. There may be a better way, but it would work as well. 0.01. Like that. So what it would do here is say, okay, I have this integer, I'm converting it to a float, so it will be 4.0, and here it will be a number between 0 and 4.0, but as I don't want 4, I want 3 maximum, I will put between 0 and 399, and then you floor the value, which means that if it's 399, it will be 3. If it's 257, it will be 2. If it's 1 something, it will be 1. And if it's 0 dot something, it will be 0. So you will make that, and then after you can go get back to 2 floats if you really need 2 integers. Sorry, if you need an integer, you do this way, and you have your integer. So that's a bit like a gymnastic, but that's important to understand that there is no way to. Oops, sorry. There is no way to do it. You have to convert if necessary. There is also something really interesting. This is the conditions. You can create conditions to have something, to make something happening. For example, let's look at this. So these are not really useful examples, but at least they explain what is going on. So once again, here, I'm going to put like a frame. This is my X. This is my Y. And this is my factor, let's say. What is affecting the result? Factor. Okay, so imagine that you say, you know what, I have this image as entry, and what I'd like if the value is greater than 0.5, so gray or light or brighter, I want to go in one direction. If it's lower, I want to go the other way. So we can do that because there is some nodes which allows you to create condition, starting with the if node, if else, which is this one. So how does it work? You have this condition. Well, there is 3 inputs and it's well explained. Here, the first one, you are going to define the condition to be true. So we are going to put that here. And then you will, if it's true, well, you will output this result. If it's not true, you will output this result. So in my case, I said, so we are here. Oh no, I have my input 0, which is here. So this is what I want, so I have to call it again before. So let's make some space. Oh, let's not be afraid of condition. I will say, first I will need a sample to grab the position of the value of my input. And then I will say, if the value that I just grabbed here, just let me go here, do like that. So if this value here is brighter, so you say greater or greater or equal, it's not big deal here, then medium gray, so it will be 0.1. I need a float. So this is my condition. Okay, now what's going on? If it's good, well, you know what? I think I will put in the factor, I will say use, will say that. I'm going to put that here and this. So I say, okay, if it's true, well, output that. And let me check the value. Didn't change that much right now. Let me push that. It's because, let me put that to 0. And you will see that we will have a small bug right now. And we will explain why. So set as output node. And now, not that bad. So if I move this, okay, you see that just the one which are brighter are affecting. Why? Because I said, if it's true, well, return, the factor will be this one. But if it's false, right now the factor will be 0. So it does multiply by nothing. You see, this is made to be multiplied here and to be added here. So what it says is, if it's false, do nothing, and that's exactly what it does. Now, what I'm going to do, I said that I wanted to go the opposite direction. So to do the opposite direction, well, if you want the negative of something, the opposite is the negative. So we are going to take the negative of this. And this is easy, so I have my result, and I could make a multiplication by -1, but we already make a node for you, which is negation. So if I do this, and I put it here, now it goes the other way. So let me play with this parameter. You see that it goes in one direction and the other. Maybe I'm going to remove the factor here, so we make things moving the same way in one direction and the other. Totally useless, but I think it illustrates the points. Once again, if you have questions in the chat, don't hesitate. That's a good moment. I'm showing stuff like this, but you may have some specific needs or question about how it works. I hope it's clear at the moment. This is a pretty simple example. We can build a lot. For example, I can use like more complex math. Obviously, if you look here, once again, you have like lots of stuff, vector. If you go below, you start to get some logarithm, exponential, power of 2, sine, cosine, etc. A good thing that I like to do is, for example, okay, I'm going to delete all of, do I delete all of this? Maybe I'm going to work here. There is a website, let me show you here, which is called desmos.com, and it's a graphic calculator. So I put it in French, I would say in English, okay, like that. There is a graphic calculator. This is great because it allows you to visualize the result of an operation and also to play with it. For example, here I can say y equal 2x. And you see, you have like the result of this. But I can also write, and I have like also helper here, so I can use operation. I think there is, here you see there is function, sin, cosine. So I could say y equal sine x, and you see how to make that curve. So if, for example, you say, oh, you know what, I want to make a height map which is like that, well, this is a good start. And you can start to play and see what's going on. For example, here it says, we're going to put like that, but what if I put 2 sine x? Oh, we say, okay, change vertically. And if I do sine 2x, okay, it's horizontally. So here, there is many different sites. I like this one, I don't receive anything, and I think it's free. This is a good reference to start creating curve, making connections. So I can use that, like for example, y equals sine 2x. Let's try. So I will say, okay, I say here goes from 0 to 1 here, but there is a node, so I'm going to do Control D, take my $post here, and first thing I'm going to do, as we said, we have the value which goes from 0 to 1. 0 to 1, if I take a swizzle, 0 black, white, 1 equal white. So if I put this, you see that I have a gradient like that, which is interesting because it means that I can use this value and play a bit with that. The website, sorry, is desmos.com. Very helpful in my opinion. So now I have this value, and by the way, now we said, okay, we have this value. We go from 0 to 1. There is a node if I want to replicate what we have seen here. It's from 0, 1, -1. I can go from -1 to +1 if we want, just by using a node here, 0, 1 to -1, 1. So just doing that. Oops, what does it need? I need my swizzle here. So now set as output node. So here, of course, it's -1, but you cannot go darker than black, so you don't see it. That said, if you want a hack, sometimes if you want to work with minus, for example, or something more than 1, what you could do is go to your pixel processor here and go to the base parameter, and in the output format, you say absolute to choose it yourself, and you say, I want a 32 bits precision. It's a HDR. So what it does, let's compare. First, I'm going back here. So visually, you don't see any difference. But let me make a bit of space. If I show here, so this one, sorry. So if you look here, you see that the value RGB, so I'm going maybe to make a zoom. RGB is, I cannot show the two at the same time, so you have to trust me. So RGB is 0, 0, and if I go here, it will be up to, you see, the value 256. But below here, it stays 0. Now, if I pass to 32 bits, what's interesting, it's, you see, you have the values which are still in the image, which means they can be used by Substance, by the pixel processor. And if I go here, it will go up to, you see, now it's not 256, it's 0, 1. And if I have higher values, it will be stored as well. So if you start making some math with negation or number higher than 1, just pass your output format in 32 bits. I'm going to leave it this way, by the way. Okay, so now I have that. And what I can say, let's look at Desmos. 1 second. We said, okay, I want to repeat it. So I want to multiply x before to apply the sign. So here I have my, oh, I didn't do it. So here I'm going to do the sign here, like that, output. It doesn't change right now, but if I go here, here, sorry, and let's multiply and see how it goes. Should I multiply before? We'll see. So multiplication, a float, and so first it will be all black because it will mean sign 0, but now let's go and move that, and let's put 10, for example. And you see, you start creating a repetition. So you are saying, okay, so it makes some bands like that, interesting. But once again, here, you see it goes negative, positive, negative. So if I go in my model here, let me hide this for a moment. Like that, I'm going to make some space, and we are going to look at our 3D view. So let's create a new one. Sometimes I don't know why the view. Windows, 3D view, rounded cube. Can I do new 3D view? Okay. I want to put a plane. I hope it will work. Sometimes I don't know why. Maybe I have to put base material here. That's the joy of making a representation. So let me save this and open again. Okay, it doesn't let me cube. I don't know why. Okay, so I won't see it. I will have to fix this with the team. I noticed this, or maybe if I do file, open, recent package, let's just use that, which is something else. Okay, now I have an object. I have to show this bug to the team. Now it's there. So I'm going to put like a plane, high res, like this one. And I'm going to say, okay, this is, I'm going to put this as my height map. That will be here, and this as my normal map. So you see it start moving. And now if I go into my material setting, edit, I can say, okay, let's move a bit the scale. And you see that it exactly corresponds to what the curve we have. We have to find a good scale here. I think 10 would be fine, maybe something to adapt, 8. And if I compare to my curve here, that's exactly the same. And if you change, if you manage to get the math that correspond to that you make in Desmos and apply it there, so in my case it's here, that would work. Now I can control here the frequency like that. And here, well, this is a trick because if I do another multiplication, it won't work exactly the same because the amplitude is also defined by the material, but still it should work. Let's put 2, and I'm going to put that here and see this as output, and let's see. Yes, you see it changed also this way. So you can really control. You can almost, if there are some geeks out there, you can almost create your own graphic calculator here. Maybe there would be a problem exposing the values, but still, that's something that you could do technically, which in my opinion is great. So don't forget, I think even, you know, sometimes people were asking, okay, what's the point of mathematics? Math, and especially not mathematics, but more sine, cosine, etc. I won't use this in my life. Well, now you have a good reason, so you can call your math teacher and say, okay, you were right. That's interesting. And once again, I can change the frequency and get something like, you see, this is super clean curve. Sometimes we want to do that with a blur to get this kind of curve, but this you have like the pixel perfect curve. Is it okay at the moment? Everyone is clear. What else I want to show you? Yes, something new. I'm just going to show you how it works, even if we won't build a full example. This is something new. I think it has 6 months or something like that. We introduced. So let me remove this for now. Or you know what? Let's keep it here. We are going to read below. We have introduced the while loop. So what is it? If you know a bit of code, you know that a while loop is something that will say, okay, while this is true, continue to do that. And it allows you to make controlled repetitions. And this is really important. Sorry, I'm going to drink a bit of water. I don't want to die live. So this allows you to build a lot of things. It opens a lot of potential. I played a bit with it, but just on a theoretical way. But today we are going to see the theory, and hopefully in the future I will create a useful example. But let's see how it works. So once again, we want to say, for example, while this is true, do this. So this is a way to increment a value, to apply an effect multiple times. In my case, what I'm going to do first is, well, let's look at it. You have 3 entries. So you have the init value, the init, which is the value at the start of the loop. Then you have the exit condition, and be careful because I made this live stream in French 2 days ago, and I didn't take the time to read that, and I thought it was the condition while this is true, continue, but this is the contrary. Until this is false, which is this will be applied. So here it's the exit condition when the loop will end. And this is what is going to be repeated after each loop until it ends. So let's create that. First of all, I'm going to create a float, for example. Let's say a float. Let's create an integer. It's okay, it's the same. And it will be, the init value will be 0. So you see that this is dynamically changing. So even if it was green at first, no worries, this will be changed. Then here you have to find an exit condition. So the exit condition, in my case, will be when this number is superior to 10. And here you see we have a problem. Because, okay, we say this number, but which number exactly? We don't know. So we have to define this, because if I put, for example, I'm going to make something that does not work, but I'm going to explain after why it does not work. So I'm going to use something to make the comparison and the exit condition, and I say greater to 10. So I need an integer like this. I will put this to 10. So what is greater to 10? I cannot link that, of course. It does not work. If I take the, I can say, okay, I will make this value, but good luck to have 0 greater to 10 one day. It won't happen. So what we have to do is to create a variable that we store this value first. So to do this, here I'm going to use a node that you may know if you have seen my fxmap live stream. It's the set node. What it does, it allows you to create a variable. So I will call it my value, but you can give the name that makes sense depending of the project. And please use name that makes sense, because if someone else look at it, it's better to put like incremental erosion, for example, than X, because X, okay, it's social networks, we know that, but what else? It has to be, this is more to work in a wise way. So now, 0, what we created is my value, a variable which is called my value, and the initial value is 0. So this is the start. And we say, okay, this is the init value. So what we created as init value is this variable my value set to 0. Now what I can go here and to say, I'm going to get a value which is an integer here, and I will say, let's look at the list. Oh, magic, we have it here. So I'm going to get my value, and I say, while my value is greater to 10, well, do this. So you may have guessed it, here in the loop body, whatever we do, we also have to affect this variable, because if not, well, it will remain to 0. So let's do that. What I'm going to do is here, I'm going to make a multiplication by 3, for example. Sorry. Integer and by 3. So once again, I'm going to call this one. I won't take this one, because if not, it can be mixed, because here I will do something, an operation which is important. So I will do get integer like this, and here my value once again. So what does it mean is, for each time get my value multiply by 3, sorry. Sorry, I made the Spanish live stream yesterday. So multiply by 3, and that's it. But the thing is, okay, it will take 0, multiply by 3, and return it. And the next loop, it will take 0, multiply by 3 again. So what you have to do here, before to send to the end of the loop, you have to set it again with the new value. And actually, I don't want to multiply by 3. I want to add 3, just to make it more visual. Not a big deal, but it's just to... So it's more understandable. So my value at 3. So once again, if I do that, it will return 3, 3, 3, 3, 3, 3. Nothing. So it will the loop will be forever. By the way, there is like a firewall for this in order not to crash. Designer, you see that you have a max iteration here. So if, for example, after 32 iteration, the condition is not met, it will stop anyway. This avoid to to loop forever. So here, what do? We just have to add a set node here, and I will put, oops, sorry, my value again. So watch out with, it has, if I'm not wrong, to be, it's size sensitive, so case sensitive, sorry. So now it should work. So I'm going to put this, you know what, I'm going to just copy all of this here, and I'm going to go to the value processor. So we see the value, it will be better. Up here and set, just double clicking here, and set this as output. And you see now it's 12, so it worked. It means that what it does, first the value was 0, it checked at the first loop, is it bigger than 10? No. So okay, we are going to add 3. So first loop, it was 3. Second loop, it was 6. Third loop, it was 9. And the last loop, it was 12. So after the fourth loop, it returns the result, which is 12. So it works. I hope it makes sense. I'm pretty sure I've been seeing people starting to create blur tool with that. I honestly didn't play a lot, but I will, because this is super powerful. Especially there is some erosion algorithm that may be interesting to make with that, to make terrain, erosion, etc. Something to try. Before, what people were doing is they were repeating blocks of nodes up to the point that they were happy. With this, it should simplify a lot. So I think we have seen the most important concept of the pixel processor, value processor, some stuff you can do, the importance of playing with the data, making sure to convert the data to your will, and also understand what you want to make with them, and understand also that values are also colors and colors are also values. So gray, mid-gray is 0.5, etc. So this way, even for designer and the material comprehension, it's really useful. You have to understand that it's not just color. For example, here, if we look at this material, here, of course, the base color is a color that we are going to visualize, etc. This is true. The normal map, it's not that much a color, it's a vector. So it's defined a vector. The color is used where the different channels of the color are used to store a value. Roughness, same thing. It's not a color, it's a value at the end. Color is just a way to store a value between 0 and 1. That's it. Metallic, same. Ambient occlusion. And height, it's the same. So just don't forget that. That will help you a lot in your material creation in general and in the pixel processor in particular. I'm going to put the chat to see. I don't know if you have any question. I'm going to wait at least 15 seconds because there is like a delay of 50 seconds between when I'm talking and when you are watching. So anyway, I really hope that you have learned something, that it was useful. If so, like and subscribe, of course, you know that. In 2 weeks, I won't be there. I will be on vacation. So I will be there in 4 weeks. I don't know yet what I will do. I think, I'm not sure yet, that I will talk about how to create content for Substance 3D Sampler. So getting from designer to sampler. Not decided yet, but that will be a topic that I will tackle soon. Okay, I don't see any question. So once again, thanks for watching. Like, subscribe, follow me everywhere I am. Well, everywhere you are as well. I am on x.com, I am on LinkedIn, I am on Discord, Reddit, etc, etc. If you have any question, don't hesitate to ping me, contact me. And if you have ideas, I'm really interested by ideas or stuff you would like to make, whether it's for Painter, Sampler. Even right now we have filters for Photoshop. So I know I will create some because it's super easy and super fun to do. But once again, you have some great ideas. I made some content already based on your ideas, so don't hesitate to share with me. Thanks again and see you in the next live stream. Bye bye.